Now, after having discussed the first four things of the statistics, that means mean, median, mode, and range, here we are to discuss about the standard deviation. The standard deviation looks like one of the most troubling part of the statistics topic, so we'll just go slightly slow, and then there are more videos that I'm planning to make on this topic. Let's quickly understand what is the standard deviation primarily. So the standard deviation is nothing but it's just a measure of separation. So that's the easiest way we can internalize this concept. It's a measure of separation. That means the standard deviation tells us how much is the separation among the terms, which means higher is the value of the standard deviation is the indication of the separation between the terms is larger, and if the terms in the set are closer to each other, then the standard deviation of the set is supposed to be lower. Now we will discuss it with the help of an example, but let me just quickly finish some basic theoretical part about it first. It is also the average separation of the terms, average separation between the terms, and the average separation is calculated from the mean. Therefore, the standard deviation formula is actually represented by a square root of sigma xi minus x bar whole square divided by n, where x bar is the mean and xi is each term in the set and n is the number of terms. However, it is strictly prohibited the use of this particular formula. We should never ever use this formula. Without the use of this formula, basing our understanding on the fundamental principle of standard deviation, we should be able to answer all the questions. Therefore, not mentioning this formula is actually a useful thing in my classes. I generally do not mention it, but here I think it's paramount that I mention that the standard deviation formula is not something that we are supposed to use, especially for the GMAT questions. So now, having understood that it's a measure of separation and the average separation between the terms, how do we look at the separation? Then the bottom line is we always arrange the terms in either ascending or the descending order first, and then we start looking at the separation between the terms. Right? So from the data sufficiency perspective, these are two things on which the standard deviation depends. Number one is the gaps between the term. That means how much are the separation between the terms. And the second parameter on which the standard deviation depends is the number of terms. That means if the gaps are kept constant and the number of terms are changed, the standard deviation value will change. And if the number of terms in the two sets are same but the gaps are different, then once again the standard deviation will be different. Yes, and some of our official questions have also considered variance. So let me just quickly include this, that variance is nothing but simply the square of standard deviation. So the effect on the standard deviation is simply a reflection of the effect on the variance as well. It just variance effect is in a way magnified than the effect on the standard deviation, because variance does the square of standard deviation, which means it magnifies the result on the standard deviation. From the basic understanding, there is also one more thing that we should know, that standard deviation can be equal to 0. A standard deviation equal to 0 means all the terms in the set are equal, which means if I consider a set such as 2, 2, 2, 2, 2, so it has 5 terms and all the terms are equal, so the standard deviation of this set is 0. Otherwise, the standard deviation, whether terms are positive or negative, it's always greater than or equal to 0. So even if I take the terms 2 50 times and I write 3 ones, the standard deviation of this set will not be 0, it will be something greater than 0. So the generalized understanding here is that the value of standard deviation is always greater than or equal to 0, and standard deviation is never negative. This also is one principle based on which several official questions in GMAT have been seen. So please make sure that you take a good note of this fact, that standard deviation is never negative, it's always 0 or greater than 0. 0 is the case when all the terms in the set are equal. Now, we will try to understand more about the standard deviation with the help of a few examples. So I have kept a really good example for us to understand how to compare the standard deviation of various sets. So here is the first example. This example basically gives us 4 different sets A, B, C, D. A has 5 terms 1, 2, 3, 4, 5. B also has 5 terms 2, 4, 6, 8, 10. C also has 5 terms 51, 52, 53, 54, 55. And D also has 5 terms, which are minus 10, minus 8, minus 6, minus 4, minus 1. And our job is to arrange the sets as per the increasing order of their standard deviation. So you have to arrange these 4 sets as per the increasing order of their standard deviation. If you are solving, if you are learning this, then I insist that you find the answer of this question yourself and then see the rest of the part of this video. Now, here, what we do at first is, first we see that how many terms do the sets have. So the first set has 5 terms, the second set has 5 terms, the third and fourth, each set has 5 terms. As we mentioned that there are two things on which the standard deviation depends. The first thing was the number of terms in the sets, which is exactly same in all the 4 sets, and the second is the gap between the terms. So here we are going to emphasize on the gaps between the terms. In the set A, the gaps between the terms are defined as 1 each place. In the set B, the gaps are 2 at each place. So from here, we should quickly understand that the standard deviation of set B should be greater than the standard deviation of set A, because the number of terms are equal, and greater the separation leads to the greater value of standard deviation. In case of set C, we have the gaps 1 again. So now we have to compare if B and C, then we understand that both have same number of terms and B has larger separation, so B will have greater value of standard deviation. But what happens when you compare the set A with set C? Both of them have 5 terms and both of them have separation 1 at each place. That means standard deviation of set A will be exactly same as the standard deviation of set C. So that's the first inference. Let's look at the D. Here the gap is 2, the gap is 2, the gap is 2, and the gap is 3. So now if you look at the gaps of these 4 sets, you see the largest gaps are available in set D. That means if you compare set B and set D, we understand that set D has greater standard deviation than set B. So the order of the standard deviation can be represented like this. Standard deviation of set A and set C are equal and they are the least. Then greater than them is the standard deviation of set B, and the largest standard deviation is found in set D. So understand one basic fact, that even if the terms in a set are very small, that means they're negative, even then the standard deviation can be maximum, because it's simply the reflection of the number of terms and the gaps between the terms. So this is how we compare the standard deviation of the sets. Usually the questions that have been encountered in GMAT are the ones in which we have to compare the standard deviation of the set of equal terms. For example, one of the questions that official questions have mentioned is the set of 10 consecutive even numbers, and another set is a set of 10 consecutive prime numbers. And the question was compare the standard deviation. So now I hope you can understand, if I call this set P, if I call this set Q, then the standard deviation of set Q is bound to be greater than the standard deviation of set P, because the prime numbers are always at a gap of 2 or larger, except just at one place. But since the number of terms is 10, which is quite substantial, so the standard deviation of set Q is likely to be higher. Now, this conceptual question is especially very important from another perspective, because there are 2 takeaways that we are going to draw from here. And those 2 takeaways are right here. Now, the first takeaway is that addition or subtraction of a constant in each term of the set does not change the standard deviation of the set. We can perceive this fact in the previous example, where we look at the set A and set C. You see, in set A and set C, the gaps are same. Each term in set C is 50 more than each term in set A respectively. That means the addition of 50 in each term does not change the standard deviation of the set. And therefore, we can conclude that the addition of a constant in each term of the set does not change the standard deviation of the set. And if the addition does not make any change in the set, then the subtraction of a constant also does not make any change in the standard deviation of the set, provided the addition or the subtraction is happening in each term of the set. That's number 1. Now, the second thing to take away is that the multiplication or division by a constant does change the standard deviation of the set, and that changes by the same factor multiplied. For example, in the previous example, we looked at one of the sets, which was 1, 2, 3, 4, 5, and there was another set B which had elements 2, 4, 6, 8, 10. So in a way, we can see that each term of set B is 2 times each term of set A. and therefore the standard deviation of set B was greater than the standard deviation of set A. Actually, the standard deviation of set B will be twice the standard deviation of A. So the multiplication and the division by a constant changes the standard deviation. Now, I did not mention here that whether it increases or decreases, because in this particular case, the standard deviation is increasing. But what if I call a set is 2, 4, 6, 8, 10, and if we multiply 0.5 in each term, then we get another set Q, which is 1, 2, 3, 4, 5. And the multiplication, once again, decreasing the standard deviation. So the multiplication can increase as well as decrease depending upon what factor is being multiplied. If any value that is being multiplied is between -1 and 1, then the standard deviation of the set will decrease. This is the multiplication. So the division rule will be exactly opposite multiplication. And if the value of factor that is getting multiplied in every term is either greater than 1 or less than -1, then the standard deviation of the new set will be greater than the standard deviation of the old set. So these are two important takeaways, and basing them, there have been several questions and official questions. So I hope they will help you build a basic understanding about the standard deviation. Now in the next video, we will discuss what happens when the number of terms in the two sets are different. However, I would like to take a pause on this video here. Thank you so much for watching this video, and if you like it, please subscribe to my YouTube channel. Thank you so much.